Hello students, we are going to discuss the last topic of P block, that is group 18th. It is called noble gases or rare gases or it is called inert gases. Noble gases, rare gases and inert gases. It has particular meaning. Noble gases means like noble behavior, means very less tendency to participate with other substances. Rare gases means very minute quantities available in the atmosphere. That's what is called rare gases. Inert gases means chemically stable. That's why it is called inert gases. So these are the three names of noble gases, and these belongs to group. It belongs to group 18. It belongs to group 18. What are the noble gases? These noble gases are helium, neon, argon, krypton, xenon and radon. So these are 6 elements. Helium, neon, argon, krypton, xenon, radon are called noble gases. Their atomic number is here 2, then 10, 18, 36, 54, then 86. So these are the atomic number of different noble gases. Using different magic number, we can know the atomic number of noble gases. These gases mainly available very minute quantities, very low percentage in atmosphere. If you see their percentage in atmosphere, percentage in atmosphere, if you see their percentage in order is, first one is argon, higher amount, then neon, then helium, then krypton, then xenon, then radon. These are the percentage order composition. Higher amount is argon. So argon is available. Higher percentage means very low, less than 1%. So you compare to total composition of atmosphere, argon is very less than 1%. So, but compared to other, argon is, the percentage of abundance of argon is highest. Then these 6 gases mainly, if you see his discovery, it was discovered mainly by William Ramsay. These gases were discovered by that British chemistry. William Ramsay, he was the British chemistry mainly involved in the discovery of noble gases. That's why William Ramsay is called the father of noble gases. He is called also father of noble gases. Father of noble gases. Because he involved in all discovery of noble gases. So these are some regarding the percentage of noble gases in the atmosphere regarding the order, percentage order. Then if you see the electronic configuration, general electronic configuration of noble gases is NS2 NP6 except helium. Helium is only 1s2. Helium atomic number is 2, that's why 1s2. But other than helium, all noble gases have NS2-NP6 configuration. That means they contain 8 electrons in their outermost shell. That's why it is called NS2-NP6. If you see the configuration, S is completely fully filled and P is also completely filled. As they have stable electronic configuration, their outermost electronic configuration is completely filled, their subshell is completely filled. That's why they are chemically stable. Why they are chemically stable? Because due to stable electronic configuration. If you see helium, S2, 1s2 completely filled. NS2 and P6 all having like this, the general electronic configuration of noble gases. Then if you see that size, atomic size, you see discuss their atomic size. Generally the atomic size we know from left to right, atomic size generally decreases. But the noble gases showing some exceptional properties, that is suddenly increasing the atomic radius. Compared to your compared to your halogens, noble gases have greater atomic size. This greater atomic size due to generally van der Waals force. Atomic size generally van der Waals radius, that is considered as a van der Waals radii. As it is van der Waals radius, so the size is greater than compared to your halogens. If you see compare, it is greater than if you see group 18 is greater than group 17 because the radius is van der Waals radius. Van der Waals radius is always greater than your covalent radius. Generally, noble gases are monoatomic nature. So when the radius will be calculated, it will be considered as a van der Waals radius. Very weak force exists between the noble gases to form the liquid or solid forms. This force is van der Waals. That's why the radius is called van der Waals radius. Van der Waals radius is always greater than covalent radius. That's why group 18 size is greater than group 17, exceptional character due to van der Waals radius. If you see the size order, generally helium less than neon, less than argon, less than xenon, less than radon. Krypton. Helium, neon, argon, krypton. This is your krypton, then xenon, then radon. But one thing, radon is radioactive. This one is a radioactive nature. Radioactive. As it is radioactive nature, it will not be considered, it will not be taken for the it will not be considered for the study of properties with other noble gases because it is radioactive, very low percentage available in the atmosphere. The percentage of radon is very low. That's why due to this exceptional behavior, radioactive nature, it is not taken for the study with other noble gases. So this is the increasing order of atomic size order. Then next important property regarding ionization energy. If you see ionization energy of noble gases compared to other high ionization energy. Compared to other elements, noble gases have high ionization energy. Why high ionization energy? Due to stable electronic configuration. Due to stable electronic configuration, noble gases have high ionization energy, because already you know, if the atom is stable, if their outermost shell is completely filled by the electrons, then it has very low tendency to lose electron. That's why as it has very low tendency to lose, so require more energy to remove electron from its outermost shell. That's why generally noble gases have very high ionization energy compared to other elements. But what are the order of ionization energy? As size increases from top to bottom, helium to xenon to radon, as size increases, so ionization energy order is helium greater than neon, greater than argon, greater than krypton, greater than xenon. So it has xenon compared to xenon, as radon is radioactive, will not be considered for the study. So xenon has, compared to other elements, it has low ionization energy. Low ionization energy is xenon. So this is regarding ionization energy, very high ionization energy due to stable electron configuration. Then another property is electron affinity. EAV, you know electron affinity. Electron affinity, you see, what is electron affinity? The energy produced during attraction of the outermost electron, that is the nucleus, and the added electron. That is called electron affinity. As the noble gases is very stable in electronic configuration, so it has very less tendency to lose and very less tendency to accept electron. Due to this very low tendency to accept and lose, so electron affinity, attraction towards the added electron is very low attraction. As very low attraction, electron affinity of noble gas is very negligible. Negligible in the sense what? Very low ionization electron affinity. Low electron affinity. Low electron affinity means tendency to attract electron is very less. That's why less amount of energy released. But there is a very important observation that as it has a low tendency to accept electron, then how can you add electron to the noble gases? As they have, suppose you are not interested to receive something. If how you will receive the something, you have to convince. You have to, when you will be convinced, then you may accept your friend's request. So similar as noble gases have very stable electronic configuration, so very little tendency to accept electron. So the energy released from the by the addition of electron is very low. But question is, as it has stable electronic configuration, that means this is the nucleus and this is the atoms. If the surroundings outermost electron is completely filled means the electron, that much of electron required in the outermost cell is already completely filled. If you see, so as it has 8 electron in outermost cell, compare this, as it has 8 electron in outermost, generally it has 8 electron outermost cell that is completely filled, so very less tendency to accept electron. So to add electron to the noble gases requires some extra energy. Extra energy is required. Extra energy required to add electron to the noble gases. So as the extra energy required, that's why electron affinity Generally, electron affinity is negative side because it is energy released. But in case of noble gases, the electron affinity is very less because due to very low attraction. To add electron in noble gases, we have to use some extra energy. That's why they have, very important this point, they have positive electron affinity. Very important this. Now, why noble gases have positive electron affinity? Because due to stable electronic configuration. As it has stable electronic configuration, very low tendency to accept electron, so that to add electron in the noble gases, we have to consume some energy, we have to utilize some energy. That's why they have positive value of electron affinity of noble gases due to stable electronic configuration. So some energy is needed to add electron to overcome the repulsive force between the outermost electron and added. This outermost electron and the added electron, to overcome this repulsive force, we have to use some energy. That's why electron affinity of noble gases are positive side. But why we are telling low electron affinity? In the sense is, as they have very low tendency to accept electron, that's why we are telling very low electron affinity. Generally, electron affinity is negative sign, the energy release is negative sign, but as here energy is opposite, that energy is needed, that's how we are telling low electron affinity. And which, due to this stable configuration, electron affinity is taken as positive side. What is the order of electron affinity? Electron affinity is same as very small size, high electron affinity compared to this. Okay, this is the order of electron affinity of noble gases. So ionization energy, electron affinity, then reactivity. Reactivity, if you see, reactivity of noble gases depend upon the ionization energy. We know if atom has low ionization energy, then it is more reactive. As xenon has low ionization energy compared to helium, so due to low ionization energy compared to other noble gases, it is more reactive. So reactivity order is xenon is highly reactive compared to noble gases, then krypton, then your argon, helium, neon, argon, krypton, xenon. Okay, then xenon, krypton, argon, then neon, then helium. Helium is the least reactive noble gases. Remember, helium is the least reactive noble gases due to high ionization energy. If question will be asked, why the reactivity of helium is least, very low reactive? Because it is small size and high ionization energy. That's why the reactivity of helium is low. But here is question, reactivity of xenon is lower. So xenon produces what type of compounds? If you see the nature, generally xenon produces oxides and fluorides. Generally xenon produces oxides and fluorides. Why oxides and fluorides produced by xenon? Because as it has high ionization energy, so highly electron affinity, highly electronegative elements like oxygen and fluorine can form compound with xenon. As it has very low tendency to lose electron, that's why high electronegativity elements, high electron affinity elements can combine with which one? Xenon. That's why xenon produces oxides and fluorides, because oxygen and fluorine have high electronegativity character. That's why it produces oxides and fluorides. This is regarding the reactivity. Then melting and boiling point, if you discuss MP and BP, if you see Generally they have generally low MP and BP. Why low MP BP? Because generally they are monoatomic and their attraction, the interatomic attraction is very low, very weak interatomic attraction. That force is called van der Waals force, very weak force. Due to weak force, they have low MP and BP. Weak due to weak van der Waals force. Due to weak van der Waals force, they have low MP and BP. And this MP and BP melting point and boiling point increases from helium to xenon. Why? Helium, neon, argon, krypton, xenon. Why the melting boiling point increases from helium to xenon? Due to increasing size and increasing van der Waals force. That's why boiling point also increases and melting point also increases. This is regarding melting point and boiling point and reactivity. Then another important point is solubility. Solubility in water. Already you know, as they are non-polar species. Non-polar means they do not carry any charge. So they are also generally very low reactive. That's why the solubility in water is very low, very less soluble. But solubility depends upon the size of the noble gases. As they produce a weak van der Waals force with water molecule, so the force of attraction with water molecule increases with increasing size. When size increases, the attraction between the water molecule with the noble gases will be more. And this solubility in water, generally, what is the order? Helium is less soluble than neon, then neon less soluble than argon, then krypton, then xenon. So solubility increases from helium to xenon due to increasing size, due to increasing van der Waals force. But one important thing, this compound, the compound produced, the compound, that means how it is soluble. We know oxygen is soluble in water because here oxygen is non-polar, but how it is soluble? Oxygen molecule will be trapped in the cages of water molecule. So in water has so many cages, so many gaps, vacant space. In the vacant space, oxygen will gets fitted, so forming the compound with water molecule. Similarly, when xenon, helium to xenon, the solubility of xenon is highest because xenon can fit in the cages of water. So this type of compound produced between noble gases and water are called clathrates. This type of compound is called clathrates. Called clathrates. This type of compounds are called clathrates. What are clathrates? Clathrates is a compound of noble gases and water. These are called clathrates. This type of compound is produced due to weak van der Waals force between the water molecule and xenon, non-polar species, helium to xenon, noble gases. So solubility increases. This is regarding some important properties: ionization energy, electron affinity, reactivity, and your solubility of noble gases. Then generally, if you see the formation of compounds of xenon, you see the compounds of xenon, if you see the formation, xenon generally produce compounds. The tendency to form compounds is xenon due to low ionization energy. And this due to this stable configuration of noble gases, generally they do not form compound. But Bartlett first he prepared the compound, that is XePtF6. This compound is a complex compound. Complex compound prepared by Bartlett. That's why we are telling Bartlett is the father of noble gas compound. Bartlett is the father of noble gas compound. He prepared this compound in the laboratory. Why he prepared this compound? On what basis he prepared? That time noble gases do not form compound. But he compared that ionization energy of xenon is just comparable with oxygen molecule. The ionization energy of xenon is comparable with oxygen molecule. That we know oxygen molecule has very high ionization energy, and this ionization energy of oxygen molecule is just comparable with xenon. That's why he substitute that this compound XePtF6 as O2PtF6. That's why O2PtF6 already exists. O2PtF6 is already exists. But when O2 is replaced by xenon, then this compound, what is the name of this compound? Xenon platinum hexafluoride. Xenon platinum hexafluoride is a complex compound. It is similar with O2PtF6. So by comparing the property by the ionization energy of oxygen and xenon, so Bartlett replaced oxygen by xenon. That's why the xenon XePtF6 is the first noble gas compound prepared in the laboratory by Bartlett. From that day, so many compounds of noble gases have been discovered by using different temperature, different pressure, and using catalyst. So large number of noble gas compounds have been discovered. Mainly the compounds of xenon are more available because the reactivity of xenon are more compared to other noble gases. The noble gases are also available in different types of ore, in ores form. Monazite, like this. Monazite ore. So many types of ore also available of noble gases due to this nature. So these are some important physical behavior of noble gases. In the next class, we will discuss the preparation and properties and uses of noble gases. Okay? Thank you.